Just to refresh your brains, a lot of this, some of this might be reviewed. Most of the day is vocab. The math behind it is going to be pretty easy, so we should be okay there. What I want to do is I want to try to draw angles that are on some axis like this. We just got our basic XY axis, and I want to try to draw some angles on there. Okay, now some very basic angles to draw are if I draw an angle like, I don't know, let's say right through the middle here, like so. This angle right here is a 45-degree angle. Okay, that's pretty basic. The measure of that angle, that just means how wide open it is 45 degrees. Okay. Now this side right here that they start on, they call this the initial side. Okay. Basically means where we're starting. Every time we start on any kind of anything for the next little bit, we're going to start from this original axis. Everything is measured from this initial side, the positive x-axis. Okay. Now the side that we stopped on, that's this side right here, they call that the terminal side. Wonder why they call it the terminal side.
Forever.
No. The end, yeah, the term. It's where, like if you're at the airport, you go to the terminal. The terminate, yeah, it's where it stops. Okay, so the terminator. So the angle stops right there. So the angle 45 degrees gets measured from the initial side and goes up towards the terminal side like that. So I just throw a little arrow on the inside right there. Okay, so that's a 45-degree angle. You know, the other thing is which quadrant is that in? Which quadrant did it land in? We're going to be dealing with quadrants a lot. This is actually the first quadrant. Okay, when the x is positive and the y are positive, then you're in the first quadrant. Okay, then to go from there, you go counterclockwise around the axis to get the other quadrants. Okay, so quadrant 2 is where the x is negative and then the y is positive. So up here is quadrant 2. Okay,
I guess.
If I come down here,
3.
quadrant 3
And 4.
and quadrant 4. Okay, everybody okay with that? You guys remember that? That's been a little while probably since you've seen that, but hopefully we're okay. Okay. All right, now let's say I want to graph another angle. A lot of times for angles, they bring up these Greek letters, and the most common one you'll see is theta. And it's a little circle with a slash through it. And that's actually a Greek letter. There's a bunch of Greek letters. You get into college, you'll learn them in the Greek system. Sororities and fraternities, that they're in the Greek system. They're all theirs are, like theta, chi, epsilon, kappa stuff. All those are just Greek letters, okay? Now, alpha, omega, or whatever ones we have. Anyways, the most common that we'll see is going to be theta, and theta is going to be used to reference whatever angle we're talking about for our beginning. So our first one was angle, our theta equals 45 degrees. So that was our first one. And like I said, I can use whatever Greek symbol that I want. Greek symbols often represent angles, okay? So theta is one of them. Another possible one is, let's say, alpha. Okay? Alpha is a little fish going sideways, okay? That's the alpha symbol in the Greek language. Let's say I want to say that was going to be 140 degrees. Okay, so if I were to graph 140 degrees, I start on my initial side.
So, did you just pick theta for that angle
I'm just
randomly?
picking, yeah, most of the time it's theta. Theta is the most common one.
Theta or theta?
Theta, T-H-E-T-A. Theta. Okay. Anyway, so alpha, or the fish, is 140. Okay, so 140, if I start at the initial side, I'm going to go 140 degrees in the clockwise or the counterclockwise direction. That's this direction right here. Okay, so 140. Well, how far is it all the way over here? It's 180. Okay, you guys are okay with that. So 140 would land me somewhere through here. This is 90 up here. So 140 would land me somewhere right here, and I'm feeling pretty good. Now, exactly where your angle lies, I'm not too worried about it. Okay, I mean, you don't have to be exactly perfect. Don't pull out the protractor and measure it. Okay, that's just silly. But you got to make sure you're at least in the right quadrant. Okay, if you're in the right quadrant, then we'll be safe for all the stuff that we're going to be doing. Okay, so the angle from here to here, I'm going to put little arrows on here. That was 140 degrees, and that was from here all the way to there. Okay, everybody feeling pretty good so far? Not too bad. I haven't gone off the deep end yet, right?
We're still in shallow water.
We're still in shallow water. Okay, let's say my theta. Let's say I graph theta was negative 30 degrees. So all that does, all the negative does, is switch directions. That's what the negative does. So if I were to graph this, now we're going to go clockwise. Okay, so an angle of negative 30 degrees means go down 30 degrees in this direction. Would be right there. Okay, so that's where my theta would be. Okay, we okay with that? Not too bad. So the negative tells me which direction I'm going. If it's positive, I go counterclockwise. If it's negative, then I go clockwise. Okay, so I'm going to go around. Okay, so I get negative 30. Now what happens if I were to graph? Let me put a fancy one in here.
Holy crap, that's a trident.
It's a trident, yeah.
Oh my.
Or a fee. Let's see.
A fee.
Fee, 5, 4, 5. Oh, no, not 3. Yes, 3. Yeah.
Oh, thank God.
Let's do it.
Bad, ugly last pen.
Yeah, I almost screwed it up, but it's good. Okay, so we graph theta. Theta is negative 330. Now we have phi, which is going to be 330 degrees. Now it's positive. That means go in the counterclockwise direction. So I'm going to go in this direction right here. Okay. Now, where do you think that's going to land? Oh, we're right on the line. Why is it going to land right on the line there?
Because it's
Because it's 360 total, and I went 30 short. Okay, so if I go 30 short of 360, those land on the same line. Those have a special name right there. Those are called coterminal.
Ooh, see what you did there. Co-ending.
Okay, coterminal. Now, terminal, the terminal side was the side that this angle stopped on. So we have the co written in front of it. It's kind of like you're sharing. Like if you think you have a coworker or a co-employee or something like that, somebody you're working with. Okay, so same idea here. We have a terminal side that these two angles share. Okay, so they stop on the same line effectively. That's what we're saying. Okay, does that make sense? Not too bad. Okay, let's go ahead and let's say I gave you another angle. Let's go ahead and switch it up. We'll go beta, and we'll say our beta for this one is going to be 45 degrees. Yeah, we'll do a new one. Yep. We'll move that down a little bit for you. Okay, so let's say our beta is 45 degrees. That one's a pretty easy one to graph. It's in the first quadrant, and it's right in the middle. Okay, because 90 is straight up, so it's right in the middle. Makes sense. Okay, so that's going to be 45 degrees. That's where my beta is going to be. I'm just going to draw a little beta in there. It's basically a B with a little extra leg on it. Okay, now what I want to do is I want to find a couple coterminal angles that are coterminal with 45, which means give me another angle that stops on the same line right there.
Negative 350.
Okay, so which one?
Negative 350.
Negative 315? I like it. Negative 315 degrees. Okay, negative 315. That's going in the opposite direction. Beta went from here to here. Negative 315 was from here to here. Okay, so that was a negative coterminal angle. Perfect. They're going to word it kind of weird. They're going to say, give me a positive coterminal angle and a negative coterminal angle. You got the negative. Now, how'd you get the negative real quick here?
Just because that's back.
Subtracted 360, right? Just take 360 off that, okay? What's another way that we could have got to this side? So we went the positive way, we went the negative way. What if I could go around an extra time? What if I go like this?
Nice.
Like that. Does that make sense? Okay, well, how do I get an extra lap on the track here? What do I have to add to that 45? 360 again, right? One lap around is 360, okay? So I got 360 on there. 45 plus 360 would give me
405.
405, okay? So 405 is also a coterminal angle, okay? Now, how many coterminal angles could I have?
A lot.
A lot, right? I could always add another 360, add another 360, subtract another 360, subtract another 360. You can always add or subtract 360 and get a coterminal angle based on that angle, okay? Does that make sense?
Yeah.
Not too bad, okay? Now, we have two different ways to measure angles. One of them is with degrees. The other one's called radian measure. Now, I want to go through the entire stuff that we're going to do today in degrees, and then we're going to come back through it and do it all in radian, okay? Because radian is where it gets a little tough. Usually everybody dominates the degree part, okay? All right, so let me make sure I'm not skipping too much more. Two things just from geometry that I want to refresh your brain on. One was the complement.
Oh, you look very nice today.
That's right. And the other was the supplement.
Protein supplements.
I like it. You're actually pretty close to the little way I always remember to think about these, right? So let's say I gave you theta. Theta is the most common one they use to start with. Let's say theta is 30 degrees. And I want to find the complement and the supplement of 30 degrees. Okay, you guys probably remember supplement. That one's probably one that sticks in your brain. From geometry, maybe? Two of them that add 180. Yeah, the supplement's always the 180, right? So this one right here is, I'm going to put a little plus here. Add to 180. You guys remember that?
Yeah.
Okay, now the complement was the,
Add 360.
almost.
90.
Add to 90. Yeah. There was a couple ways to remember this.
You were close.
Just went the wrong way. Doubled it versus divide by 2. It's close, right? All right, so the two ways to remember this is the supplement, one you guys probably remember from geometry. Two ways to remember that. 90 is less than 180, and the C is less than S, like in the alphabet. And as far as that goes, C comes before S, and then 90 comes before 180. The other way to remember that is the complement is the right thing to do.
Right angle.
You're right, see?
Oh, Colin, where's that drawing?
Okay, right angle, 90 degrees, complement's the right thing to do, and then the other one's just the other, okay? You guys probably remember the supplement one from geometry anyways, but if we're this. Now this is 30 degrees, so my 30 degree angle, what's going to be the complement of 30? 60, okay, that's pretty easy. And what's the supplement of 180? Or supplement of 30?
150.
150.
No one can beat me.
Super fast, right? Everybody's happy? Super easy to do? These two add to 90, so it's the complement of it. These two add to 180, so it's the sum. Okay, so I just went 90 minus 30 to get 60, 180 minus 30 to get 80. Okay, so that's complement sum. You guys are okay with that?
Oh, definitely.
Yeah, we're dominating right now.
Oh,
We're
right
doing
now
So good.
Yeah, well,
We are
So
dominating.
good.
I guess you could say
Are we?
Okay, one last thing on degrees before we switch to radian. Okay, complement supplement, that stuff's pretty easy. There's actually a more precise way to measure it, and they actually call it the DMS.
It's a weird name.
It is a weird name. Oops. And actually, some of your calculators might have that button on there. Maybe.
The angle, M.
This actually stands for degrees, minutes,
Minutes,
and
seconds.
seconds. That's actually what it stands for. Degrees, minutes, and seconds. Kind of weird. You might have a button on your calculator. You won't need your button on your calculator to do that. Now, what this does, let me show you what this does first, and then you get your question in a second. This is going to be a more precise way to do any kind of angle. Okay, so let's say I was talking about the angle measure is 60 degrees. Okay, let's say I was flying a plane and I wanted to be just a little bit off of 60 degrees, but I don't want to go 59 and I don't want to go to 61. I want to be somewhere in the middle right there. Okay, the problem is we have these repeating decimals that computers don't like very much. So when they're flying, anyways. So they have this called degrees, minutes, and seconds. Degrees is the main part of the degrees. The rest of it is just like a minor tweak to whatever the degree is, okay? The minutes right here, I might have like 10 minutes, and then I might have 40 seconds. Now all this says is this is 60 degrees with a little adjustment, just a little extra tacked onto the end of it, okay? So we're going to add just a little bit to it. How you make this a decimal that we can actually like perceive and understand, how it works is you figure out how many minutes are in a, wait a second. Did I say that right?
60.
Yeah, how many minutes are, what am I trying to say?
How many minutes are in an hour?
How many minutes are in an hour? Thank you. Why did my brain just... Yeah, how many minutes are in an hour? I don't know why that stopped my brain. Yeah. All right, there's 60 minutes in an hour, okay? So what you do is you take 60 plus, you take 10 divided by how many minutes are in an hour, which there's 60 minutes in an hour. Okay, so it's 10 divided by 60. Plus, you take the number of seconds, which is 40, and you divide that by how many seconds are in an hour. Okay? So how many seconds are in an hour? Almost.
60 seconds in an hour.
3,600. 3,600 seconds in an hour. There's 60 seconds in a minute. There's 60 minutes in an hour. 60 times 60 is 3,600. Okay? So we're going to add all those together, and that gives me whatever my decimal is. Okay? So put that on your calculator, and just go to 60 plus 10 divided by 60 plus 40 divided by 3,600, and I get 60.177. 60.177. It looks like that 7 is going to repeat forever. That 7 repeats. The problem is with that repeating 7, how do you tell your plane to go repeating 7? Like, I need an exact number, you know? This right here is exact without having to take your plane and flying like this all the way and losing distance, okay? Because every time you go off, you're going to travel further. So actually planes use this as part of their navigation to do it. But it's called degrees, minutes, seconds. And you always do the same thing all the way through. You just leave the first one alone. First one you divide by 60, second one by 3,600, okay? All right, cool. So that's about all the degree stuff that I need to give to you, okay? And you guys are thinking that's okay? Pretty easy? We can get on to the hard stuff? Okay, now we get on to radian measure. That wasn't the hard stuff yet. Here's where it gets tough. Yes. All right, so we're going to have to bounce back and forth between what they call degree mode or degree measure and then a radian mode or a radian measure. You know on your calculator how you have that DEG button and then it says rad and then it says grad, right?
Yes.
This is the rad part of it, okay? This actually is the rad right here. It stands for the radian measure, okay? So your calculator's had this button on there all along, and we're still not even going to use it, funny enough. So don't worry about your calculators for now. What we're going to do is first start with a pretty basic one, okay? What I want to do is I want to figure out if I do a full circle per degrees, how many degrees is a full circle? 360. So if I start at 0, I can go all the way around and go to 360. So 0, clockwise all the way around 360. What happens if I go halfway over? 180. Okay, everybody's okay. 180. What if I go straight up? 90. What if I go straight down? 270. Okay, so that's in degree mode. Okay, that's a degree measure. And what you're doing is you're measuring how big the angle is. Okay. Now what radian measure is you're figuring how far you're actually traveling. So if I were to graph an angle, like so, right, graphing some kind of angle like that, the angle from here to here might be like 45 degrees, right? But the radian measure actually measures how far this little sector is, how far this little arc is. Okay? So there's a difference between degree measure and radian measure. Radian is much more usable. It's harder to work with, but it's much more usable as far as real-world applications and being able to plug that in to different functions and whatnot. Okay? So what I have to do is I have to figure out how far around this entire guy is going. Well, if you think about it, let's say I have a full circle right here, right? Pretend that was pretty. How far around is a full? How do I figure out how far around a circle is? Did we learn that in geometry a little bit? What did you say it again? Say it again. You think you said it right. Almost. That's the area of a circle, right? Let's say I want to find the circumference, which is the perimeter. How far around I'm going? 2 pi r. Okay, 2 pi times the radius. Okay. Now, just to make things easy for us, there's a nice fraction that converts stuff for us. We're going to dodge that. We're going to say this is on a unit circle, which means that we have a radius right here of 1, which is kind of nice because what's my circumference then?
2 pi.
2 pi. So that means that one lap around is 2 pi. This is where it gets tough. We're thinking about this stuff in terms of pi now, which is odd, but 2 pi is actually a number, right? How big is 2 pi? 6.28, right? Okay, 6.28 is about right. We just double pi. So the tough part is you can make that a decimal if you want to, but we're going to leave everything in terms of pi. Okay, everything's going to be in terms of pi. Now think about this. If I go from 0 all the way around full circle, and I go to 2 pi, right? How far is it halfway to 180?
1 pi.
1 pi. Okay, so over here is just going to be a regular pi, or 1 pi.
Wait, 1.5 pi?
There you go.
And 1.5.
Okay, so from here to here is 1 pi. Now, what if I go? Yesterday was Pi Day, by the way. So you guys know.
Yeah, it's my birthday.
14? Your birthday's on Pi Day?
Yeah.
Birthday's on, my birthday's on tax
I
day,
did.
so what's up?
Okay, yours on tax day?
Yeah, so
April
what's up?
15th? Okay, so now it's 90, it's 180 all the way over here. It's pi all the way over here. If I go halfway up here, right here, this is going to be half a pi. So it's pi over 2. Now, if I go half a pi, this was 1 pi. Down here is going to be 1.5 pi. The nice way to write that is 3 pi over 2. 3 over 2 is 1/2, right? So it's or 1.5. So it's 1.5 pi. Okay. So here we go. Here's where it gets a little bit tricky. Right? We got to do everything we just did with degrees, but now with radians. Okay. So let's start with graphing theta equals pi over 4. Start out pretty basic. Okay. Now what I do on these, and there's 3 or 4 different ways to do this. So I'm going to explain a couple, and you can decide which one that you like, which one that you want to do. Okay. First off, label your axis. Okay, that's always good to say. I'm going from 0 to 2 pi. All the way over here is pi. Right? One full circle is 2 pi. Halfway over is pi. Straight up is pi over 2. Straight down is 3 pi over 2. It's always good to start that way. Okay.
Well,
now it's weird because you have to
pi
think
over
about
2.
pi over 2.
Isn't it 1/2 pi?
pi over 2 is 1/2 of pi, right? Now this is an alternate way for you guys to think about this.
Oh my gosh.
Because decimals and
You gotta be
irrational
clear.
numbers are kind of
Yeah,
weird
right.
to put together. So this is more accurate. So. Okay, so I've got pi over 2, I've got 3 pi over 2, which is 1.5, and then 2 pi. Now, if you think about this, pi over 2 is really like a 0.5 pi. If you want to think of it in decimal terms, that's fine. It's not going to hurt my feelings, okay? This right here would equal 1.5 pi if you thought of it in terms of pi. This would equal 1 times pi, okay? And then 2 pi. Okay, now if I want to graph pi over 4, right? If I want to graph pi over 4, it means I'm traveling 1/4 of a pi. Ooh, 1/4 of a pi. Well, how far is 1 pi? All the way over here. I want to go 1/4 of the way. So I'm going to be right. Okay, so pi over 4 is this angle right here. Pi over.
Because it's just 1 pi.
Okay, 1 pi is all the way over here. I want to go 1/4 of the way. Okay, now some people don't like that. Some people like taking 1/4 of a pi and changing that. What's 1/4 in decimal terms? 0.25. This is the same as 0.25 pi. Instead, I figure, well, it's 0.5 pi here, so I'm going to go in between 0 and 0.5 pi. 0.25, I'm going to go halfway. Okay. Now, the important part about this is hitting the right quadrant. That's the important part. Okay. All right, let's do a couple more. Woo.
I'll almost make it here.
That would be great. 2 seconds.
Yeah, what was it?
YouTube.
Bam. Done. And you can just put the sign, right? I don't know what that sign's for, but we can just put the sign, right?
Man, you were just visiting me all day today. What's the deal? Who else we got? Okay, here we go. So as I look at this, and you guys are going to get a little bit better at this as you practice this, but seeing a couple is going to help. Okay, I'm going 2/3 of a pie here. Okay, so I have to think about. Tough part about this is I'm dealing with fractions, and people hate fractions and suck, right? So 2/3 is like 0.6, right? It's a little less than 1 pi. So if I were to go pi over here is 1 full rotation over here, I want to go 2/3 of the way over there. So 2/3 pi is going to land me right about there. I thought about this in chunks of 3, like a third here, a third here, and a third here, kind of like a pizza pie. Okay. So I got 3 here. 2 pi over 3 would be 2/3 of the way over to pi. Okay. Some people don't like that. Some people like thinking of it in terms of decimals. Okay. In terms of imagine that's not there now. Right? Now you might think of 2 pi or 2/3. 2/3 is a decimal is like 0.6 repeating, right? 0.6 repeating pi. So if you thought about this as 0.5 pi, which is not the best way to do it, and 1.5 pi, I'm going 0.6. Well, it's 0.5 to here, and I want to go past 0.5 to 0.6, and I know I don't want to get all the way to 1. So I'm going to go a little bit past 0.5. And the most important part right here, once again, is getting it in the right quadrant. Okay, you get it in the right quadrant, I'll be pretty happy. Okay? Yeah. Which quadrant is that? 2. Yeah.
I don't know if that since it said 2 pi that you were going off the whole thing. Like, so you went 2/3 around the whole thing. So it's 2
No. But it's 2 pi. Yeah, exactly. You have to think of it in terms of a pi revolution. And just halfway is pi. A full circle is 2 pi all around. Yep, what you got?
Just take 2/3 of 3/6.
2/3 of 1/8. Yep.
What do you mean?
Because 360 is 2 pi all the way around, right? So you only want to go 2/3 of a pi, which is 1/8 on this book. Okay?
Typically a pi is down. Can I do anything cool again? Yeah.
It's half
When
of the
people say
circle.
pi, they think of like
A full circle, like a full, yeah, exactly. I see what you're saying. All right.
Pi. That's where
We got a lot more to do, so the more off track you guys get, the longer it takes.
I thought it just said pi over 3 and be like I'd be in my mind be over the top half and then I'd be 2/3 over at the top half. That's why.
So it might help for you to change them to decimals. Think about it in terms of decimals. Yep.
Don't do it.
This one?
Yeah.
Okay, shh, I can't hear it. It's just going to take longer and it's going to suck down.
Okay, so the 2 pi over 3, I'm gonna.
What's 2/3?
Yeah, it's just the why.
Just 0.6, right?
Yes.
Yeah, so it's 0.6 of whatever pi is. Okay? Pi is halfway across, right? Or half of the full circle, right? And I want to go 0.6 of the way. Okay? So, or 2/3, right? So I want to go 0.6, 0.5 is right here. Half of a pi is 0.5. Remember, this is like a, this is a 1/2, which is 0.5 times pi, right? So I want to go past 0.5. But I don't want to get all the way to a full 1, right? That's less than 1. So it's in between those two. So I gotta hit it in between.
But wouldn't 2/3 pi be different than 0.6? Like.
No. Yeah, put both those in your calculator, it'll be the same thing. Definitely be the same thing. Okay. Alright, I gotta keep going, we're gonna run out of time.
Go. You know what I mean?
Alright, let's do a harder one. Think of pi like an x. Think of it like a variable and don't even worry about it. It's not even the pi really doesn't affect exactly what it is.
1 and 3/4.
No, shh.
Because Greek symbols have always been used for theta, and I think it's more of a tradition thing.
Weird.
So to be honest with you, there's not a really good answer. Yeah, that's our multicultural attempt at, or our historical attempt at keeping things the same. All right, so now we got a little bit more challenging one here. We got -7/4 of a pi, and we have to graph a couple of these just to get the hang of this. It just takes a little while, unfortunately. Okay.
Bam. Oh, money.
You guys are crazy loud today. What's the deal? It doesn't bother me. I know some people are not going to get this now. So I'm graphing. First off, it's negative, which means I go in the opposite direction. Okay, same as before. So I'm just going in this direction right here, and I want to go 7/4 of a pi. Okay. Now 7/4, if you think about how far you're actually traveling, that's a little less than 2 pi. Would you agree?
Mm-hmm.
7/4 is what, 1.75. Okay, so I'm going a little less than 2 pi. I'm going past 1.5 pi, plus I'm going in the negative direction. So if I go from here, this is half of a pi, this is a full pi, this is 1.5 pi, and I'm going 1.75 pi, which is going to land me right here. So my angle is going to land right there. Negative 7 pi over 4. Okay? It might help you with the 7/4, dividing those out.
I just didn't do it.
Getting negative 1.75, and then divide by pi. Yep.
But isn't it that arrow you drew the second time around, right? Or that little.
This little loop?
Yeah.
No, that's the first time around. First time around. Negative 7 over 4.
But it's 1.
7 over 4 is negative 1.75. It's almost 2 pi, right? 2 pi would be a full circle all the way around. Okay?
This is a little bit harder.
It is, but the crazy thing is, it's a little harder, but the concept is exactly
Makes
the same.
sense.
all the way
Makes
through.
sense.
You just got to remember that all the way around is 2 pi.
Yeah.
Not 1 pi.
Enough space.
Okay, a couple quick things that we have to finish on. First off, we want to find some coterminal angles, which is going to be tough. First thing, it's always a good idea to graph it first. Okay, so try to graph 3 pi over 4. See where that lands you. Okay. The big thing is figure out which quadrant it's in. That's the huge thing. If you don't get that right, then your things will get messed up later on. Okay. So 0, 2 pi, pi over 2, pi, 3 pi over 2, and then back to 2 pi. All right, so 3 pi over 4, what quadrant am I landing in there? 2. Okay, so I'm in quadrant 2, and I think I'm going to go right about in the middle. Yeah, it's going to be about in the middle, right? Now I want to find coterminal angles to that, which means I want to stop on that exact same line. Now if this were a degree, right, let's say it was 135, because it is. Let's say this is 135. How would you get the coterminal angles to that? Add 360 is one way. What's the other way? Subtract 360. Okay, so you're going to add 360 and subtract 360. The problem is if I take 3 pi over 4 and I say plus 360, that's kind of weird, right? This is in radian mode. This is in degree mode, right? So I can't mix those together, right? Well, what's 360, a full circle in radian measure? 2 pi. So I'm going to add 2 pi. 2 pi is a full circle. Okay, so I'm going to add 360 or 2 pi. I can just add those together. Now, once again, we have to work with fractions just a little bit here, but I just make a quick common denominator there, right? So I put a 4 on the bottom here, 4 on the top here. So my denominator is 4, and I get 3 pi plus this will be 8 pi, so this is going to be 11 pi over 4. Okay, so 11 pi over 4 is my coterminal angle to 3 pi over 4. Stops on the same line. Okay? Now you can double check that. What's 11 fourths?
2 times 3 plus 4.
Yeah, well, if you divide it, 11 divided by 4, what's that in terms of decimals? 2.75. So it's 2 3/4 of a pi. So I want to go 2 pi and 3/4 more. And it lands right on the same spot. Okay? Now to get the other coterminal one, just subtract 360. Well, we can't do 360. We have to do radian mode. So I'm going to go 3 pi over 4, and I'm going to subtract 360. Okay? Can't subtract 360. Switch that to what 360 is, which is 2 pi. Common denominator again. So I need common denominators of 4 and a 4. So 3 pi minus 8 pi. So negative 5 pi over 4. Okay, so negative 5 pi over 4 and 11 pi over 4. Those are your two coterminal angles. Okay? Feeling pretty good? Not too bad? Now you can check that. Negative 5 pi over 4. 5 over 4 is 1.25, right? 1 1/4. So in the negative direction. So I go 1 pi and a 4th pi lands on the same line. Okay? So I'm feeling pretty good about that. Okay, so that's coterminals. Pretty easy. Just add 360, subtract 360. Nothing crazy about that. Okay? Complement, supplement. Let's do those real quick. And then I'll show you how to convert. Okay, now complement. What do complement and supplement stand for? Add 90 and 180, right? This was plus 90. This was plus 180. So those add to 90 and they add to 180. Okay, now what's the 90 and 180 in terms of pi?
1/2 pi or pi over 2.
Yep, pi over 2 or 1/2 pi, good. And pi. Okay, so actually we have to use just the pi versions of them now. So if I gave you an angle, like theta is pi over 4, and I want to find the complement and the supplement of that. Okay, the complement, I have to find some angle that adds to pi over 4 that gets me to pi over 2. The easy way to do that is just subtract 90, 90 minus whatever my angle is. That's the fastest way. Okay, so I'm going to go pi over 2 minus my angle. So the complement's going to be pi over 2 minus pi over 4. Okay, I need a common denominator. So I'm going to multiply by 2 on the top and the bottom on this one. So 2 pi over 4 is going to be 2 pi minus 1 pi is going to be 1 pi over 4. So the complement of this guy is 1 pi over 4. 1 pi over 4. Notice if you add those together, what do you get? What's pi over 4 plus pi over 4? 2 pi over 4. That reduces to pi over 2. Cool. So it adds to 9. Okay, so we can check those add to 9. The supplement adds to 180, which means I have to take 180, take away my angle, pi over 4. So I'm going to go pi minus pi over 4. Common denominator. What if I told you that theta was 45? How would you get it? You go 90 minus 45. Right?
Teach me about myself.
Okay, you're right. Yeah, I should teach you. So common denominator 4. 4 pi, take away that 1 pi, I get 3 pi divided by 4. So that's my supplement for that guy. Need something. Keys? Oh, they're in my coat pocket. You taking the truck? Oh. All right, so pi over 4 is the complement, 3 pi over 4 is the supplement. We're pretty good. Now you can just check the answer real quick. Add those together, and it should equal the supplement. It should equal 180, which is pi. Okay, so if I add those together, pi over 4 plus 3 pi over 4 is 4 pi over 4. 4's cancel. We get pi. I know. All right, complement, supplement. We kind of okay on that? I know, I'm running out of time. I had to police a lot today, feels like. So let's do the converting. That's the last one. You guys are going to like this. This one's going to be good. No, we haven't. Interesting. This is going to be the nice way for us to go from a degree measure to a radian measure, and a radian measure to a degree measure. Now, if I gave you the angle pi over 4, right? You guys graph pi over 4. You guys should probably guess what angle that is, like as far as degrees go, right? Pi over 4 would be a fourth of the way up. So what do you guys think that is? 45 degrees. Now, what I'm going to do is I'm going to multiply this by 1. I'm going to be tricky. I'm going to multiply this by 1. Because if I multiply by 1, nothing changes, right? Everybody okay with that? Okay, now 180 and pi are the same thing. Right? If you were to think about the graphs, where they land on the graph, pi and 180 land on that same spot, right? So if I multiply by that, what happens when I simplify that? Well, the pi's cancel, right? I go 180 divided by 4. What's 180 divided by 4? 45 degrees. Okay? So we can take any radian measure we want, 2 pi over 3, and I can convert this to radian or to degree measure, which is kind of nice. I suck at graphing 2 pi over 3. What if I just converted it? Pi's cancel. Okay, pi's cancel. Get 60 here, I get 120 degrees. Think about where 2 pi over 3 was on your notes. Would 120 match up with it? Yeah, pretty good. Okay, so we can go from radians to degrees real easy. We just multiply by 180 over pi. Okay. Now, what if I want to go backwards? What if I want to go 120 degrees and write that in radian form? Yeah, multiply this by pi over 180. Just flip it over. Okay, so it's always 180 over pi or pi over 180. Always one of those two. Now, here I want to leave this in terms of pi, which means you don't want to go 120, multiply by pi, divide by 180, and get some nasty decimal, right? You want it to be kind of a pretty fraction with pi's in it. So all you can do is leave the pi alone and figure out what 120 over 180 is. We just need to reduce that. Now, there's an old school way to do it. We can just divide. They're both a 0 on the end, so we can take the zeros off, divide by 10. 12 and 18, reduce that, right? 6 goes into both those, so it'll be what? No. 4 goes, no. 6 goes into both those, so it'll be 2 and a 3. So it'll be 2/3, or 2 pi over 3. Okay? Or, you can press a magic button on your calculator. I'm sure you guys know which one that is. On mine, I can just go 120. Oops. Oh, sorry. Divided by 180. Get a decimal. It's that pi. I just go, man. Mine changes mine to 2/3. Awesome. Okay, now your calculators probably have a button that says like A and then B over C, some kind of button like that.
Super button.
Super button. That button will actually do that for you, so get used to working that. Okay. Likewise, let's do one last one. If I have 45 degrees, if I want to convert that to radian measure, I multiply this by pi over 180. I leave the pi on the outside. I don't mess with the pi. I know it's going to be some fraction with pi, and I'm just going to reduce 45 over 180. So you just figure out that goes in there 4 times. So this would be a 1/4 pi, or pi over 4.
How do you say that?
1/4 pi. 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 1/4 Okay, so converting back and forth is kind of a nice thing to be able to do. Okay, I almost didn't show that to you, but it'll save you a little bit of time on some of your homework
No,
possibly.
'cause it's
A way to
extra
check your
work.
answer, and it's not extra work.
Just be smart enough to do it the normal way.
Be smart enough to do it.
Would you be so kind?
Yeah.
I'm actually kind of comfortable with this
Okay, so
stuff.
you know how like my calculator
Question though.
Yeah.
When we move on, are we gonna have to work with circles that don't have a radius of 20?